Audio Jungle. Audio Jungle.
So, all right. Now we have a uniaxial stress system. Uniaxial stress system, and this is suppose one material or rectangular bar we can say. So uniaxial means we have load which is nothing but in x direction. Just say this is what P. Load is what P acting here. But what about and obviously when if you talk about the shear stress, so you may say like okay here the cross sectional area is suppose A, so you may calculate sigma x is nothing but this load P divided by A. Actually this is the resistance a force divided by area, but at equilibrium this applied load and resistance force will be same. That already we had discussed how that stress will be induced, that we already have discussed. So this is the one thing when the uniaxial stress system we have, and for this particular plane we are calculating what is the stress, and that for this plane we have area. But this is the case one, okay, this is the case one which is the basic one, but now if this uniaxial stress system we have, but now the plane is what not normal, this is the normal plane, okay, this is what normal plane. For the normal plane we have written the stress, and this value is nothing but sigma x is equal to P by A. All right. But what about when we have the plane which is not normal, which is oblique? So oblique in the sense there is the plane is what inclined from the horizontal. The plane is what suppose inclined with angle theta. Then at that time what will be the stress acting on that plane? Obviously because here it is exactly acting on the normal. So this is the plane. For this plane we have the area of this plane, and the load is what acting P, and area is nothing but A. So you said stress is nothing but load divided by area. So this is for the normal plane. But at the same time if this plane is what inclined like this, so that time normal stress will be acting sigma, and that is okay. Like here normal stress we got here exactly 90 degree. So normal stress will be acting for this plane, but at the same time we have a that tangential stress also. Okay, that time we will have a tangential stress also. So tangential stress means tangent to the plane. So this is what plane here. This is the plane. But what about this plane? We will not get any shear stress on this plane because this plane is what normal. Like any load, suppose maybe load is what on x-axis or maybe load on y-axis. But if the load is what at some inclination, suppose this load is nothing but r. So this load from the horizontal, if it is making theta angle, so for the x we will say that load rx means in horizontal direction what will be the load? So it will be r cos theta, and what will be the load in y direction? It will be r sin theta. So why we got these two components? Because this resistance, which is the resultant, not resistance, this resultant load, which is acting at theta degree from the horizontal. So there is some, you can say this resultant force, we have an inclination from the horizontal, or at the same time from the vertical also you can say. But if it is acting in x direction only, so that time what will be the load? You can say Rx is equal to R, because this R is what acting in x direction only. It is not inclined. If you say what is the force in y direction, you may say it is 0, because that load is what acting in x direction only. But if the load resultant load is acting from the horizontal with some angle, then both component will be there. So in the same way, if the plane is what normal plane, then only you will get normal stress. But if the plane is what the oblique plane, this type of plane called as oblique plane. So if the plane is what oblique plane. If the plane is what? Inclined. Okay, if it is inclined from the horizontal, you can say this is the horizontal, this is the horizontal. So from the, and this is the, so this plane is what? Acting from the, I mean inclined from the horizontal with angle theta. So that time two stress you will get, one is shear stress, another will be the normal stress. So if uniaxial stress system you are talking for the normal plane, so this is the basic analysis. But now you are going to discuss what will be the uniaxial stress on oblique plane. If there is oblique plane, okay, then two stresses will be appearing here. That two stresses are normal stress and shear stress. All right, that now we are going to discuss. So our discussion is what now? Uniaxial. So uniaxial stress on oblique plane. So if it is so how you will get that oblique plane? So you can say, suppose this is the bar, this is the you can say cylindrical bar now. Okay, this is the cylindrical bar now, like this. Here, this is the cylindrical bar, like this. Now this bar is what? Kept here along x-axis. Now for this bar, if this bar will be cut in such a way that inclined face, you might have seen inclined face you should get. So if you project this, here, so how this will be appearing? It will be appearing like this. So this plane will be appearing like this, because you have cut that. So how it will appear? Again I will draw. Hope you understood this. So the same bar, if you cut with one another inclined plane, then this bar will be, this side it is as it is, and this portion you want to show. So you just say this is nothing but P Q. So if you show this P and Q, then it will be like this. So this will be PQ, or just give me time. So more it will appear. I should increase this length. If you get cut this cylindrical bar by inclined plane, so it will appear like this. It will appear like this. Okay. Now, so here you can say, take this the PQ plane you have here. So now this, for the PQ plane I can draw the highest line. So this plane is now inclined plane. Okay, this plane is what now? Inclined plane, and obviously from the horizontal, this plane I can draw this horizontal line here. So this plane is what? Making angle theta. Actually this inclination you may get if you draw one vertical line here. So I will show the angle, so it will be very clear to you. So this is the vertical line. From this vertical line to this PQ angle is what? Theta. Okay, PQ angle is what? Theta. Similarly, obviously this angle will also be theta. So now this, you can say this is the vertical. Okay, this is the vertical. You can say here it is, you can assume this is suppose the vertical. So from the vertical it is making angle theta. Okay, now if you exactly want to get the normal stress, so normal stress means exactly normal to the plane. So if this is the plane, so normal to the plane means this will be normal to the plane. So here normal to the plane you will get one stress called normal stress. Now it's very clear, simple trigonometric. So this angle, because this is what theta, so this angle will also be theta. Okay, this angle will also be theta. So you can say, so from the horizontal this plane is what making, you can say angle theta, or from vertical it will be the same only, because if you build this, so this theta will be 0 and this theta will also be 0, and that time this plane will become normal, exactly normal. So from the horizontal you can say for the whatever the load we will get, that sigma n will be shifted in x direction if theta becomes 0. So that will be the previous case. Huh? So hope this one angle is what clear to you. Now for this particular, you will have two stress. One is sigma n, which is normal to the plane, and another which is tangent to the plane. So this is the plane. So tangent to the plane means this one. So this stress will be called as a shear stress. So tau is nothing but tangential stress, which is nothing but tangent to plane, and sigma n is nothing but called normal stress, which is nothing but normal to the oblique plane. Better you write oblique plane. Oblique plane. Similarly, here also you can write tangent to oblique plane. Okay, tau and sigma n. So I am not going in so much detail for this, but derivation and all, just concept I will explain with the diagram. I will explain like where the angle is forming and where is the normal plane, where is the tangential plane. Then I will write the direct result. Actually, we have derivation, but derivation not important at all. So now, from where you will get? So we'll take the standard case. What is the standard case? Now check. This is the bar. You can say this is the bar. From where you achieve this oblique plane that I'm going to show you. So this is nothing but here. Check. The load is what acting P here, like this, and they will say there will be some inclined plane for this bar. So inclined plane is what, this one. Okay. Now for this inclined plane, they are saying just calculate what is the normal stress. So normal stress for this inclined plane will be what? Check. Check this angle here. This is what theta, right? So you can say this is theta. Then in the same way you can say this is the inclined plane. So from the vertical, this plane is what making suppose angle theta. This angle is what theta. So now this plane we can take outside. We can say this is nothing but A, B, C. So we have this inclined plane. We can cut this. Now it will be like, check. We have a plane like this. So this is what A, B, this is what C. This angle is what, you can say it's theta. So now for this plane BC, what is the inclined plane we have here? So we have inclined plane BC. So over this inclined plane we need to get that stress, which is nothing but first normal stress. Second will one more stress we will have, and this stress will be called tangential stress, sigma n and tau. Okay, sigma n and tau. So sigma n is the normal stress for the BC plane, and tau is the shear stress for BC plane, I am saying. Okay, so now how to get this result? So again it's very simple only. If you check, we have the component wise analysis. We can say for the y plane, if you take the normal area which is A. So for the y plane, if you want to calculate the area, then it will be x sec theta. A sec theta. So that if you want to go for the derivation, so in that way we can go for the derivation. But here direct result I will write, and I will show you how you can compare with the normal case. Okay. So this is the BC plane I'm saying. Okay. Now what will be the normal stress on plane BC, which is inclined. Okay, so normal stress sigma n. This is the derivation. 2, 4, 5 steps you need to do, but here directly I am going to write. It is P by A cos square theta. Okay. Similarly, what is the shear stress on plane BC? So shear stress will be tau is equal to, it is nothing but P by 2a sin 2 theta. Okay, you just think like, if this plane BC you want a normal plane, BC, where is the BC? BC is here. If you want this BC as a normal plane, then this BC should overlap on CA. Okay, if it is overlapping on CA, then what will be the theta? So theta will be 0. To become normal plane, what should be the theta? So BC we have inclined plane. Again I am saying BC is the inclined plane. And for the inclined plane, I have written this result P by A cos square theta, which is normal stress, and shear stress tau, which is nothing but P by 2A sin 2 theta. Any textbook you can take, the derivation they have given there. Okay, here it is not required. I am directly writing result, but I just want to compare with the normal plane, so it will be very clear to you. So CB is the inclined plane with angle theta from the vertical. Now if you want this CB inclined plane as normal plane, then this CB should overlap on CA. So that time theta should be 0. So if you make theta is equal to 0 here, so what is the cos square 0? I mean cos 0 is what, 1. So for the normal plane, what is the stress? P by A. I have here only given to you. What is the, for the normal plane, what is the stress? It is P by A. But now your plane is what, suppose inclined, so that time obviously, and it is inclined with angle theta, so obviously that obliquity, that angle will come into picture in the formula. So this obliquity, this angle is what coming here, and this is the simple proof only. It's very simple proof. So P by A cos square theta. So if you want to check this BC, because inclined plane, if you want to make normal plane, then theta should be 0. You keep here cos 0 is what, 1. Hence again sigma n becomes P by A, which is for the normal plane. And for the normal plane, what is the shear stress? It should be 0. Now check sin 2 theta you got. You said theta is nothing but 0 for this. Okay. For the if this BC is inclined and if you want to normal plane, then this theta should be 0 here. So if you keep here, then you will get sin 0. So if you keep sin 0 here, sin 2 theta, which is nothing but sin 0, you can say. Sin 0 is what? It's a 0. So this tau will be 0. And that you know, for the normal plane, only normal stress you will get. There is no shear stress. Here only I have explained that. This one we had discussed already. So if you are saying for the normal plane, this only normal stress you will get, but for the normal plane, what is the shear stress? It should be 0. But for the inclined plane, if the inclined plane or oblique plane we have, then sigma n will not be 0, and in fact tau will not be 0. There will be value. Hope this one is clear to you. So this result I have given directly. You need to remember this result. Okay, it is important. Till now they had not asked question, but if they will ask for the oblique plane, then we should know. Always remember theta. I have, for this formula I have taken this theta. Maybe they will give theta for this. If they have given theta here, then what will be this angle? This will be 90 minus theta. So everywhere you have to keep 90 minus theta. Always remember for which angle I have given this formula, for this angle. In examination or any problem, they have given this angle. If they have given 30 degree this, then what will be this angle? It will be 90 minus 30, 60. So you have to, for this formula, you keep 60. Don't keep 30 because they have given 30 for this angle. And I have given formula for this angle theta. So hope you, this manipulation you can do by your own. It's a simple one. It's not a difficult one. Okay. All right. Now, if I say I want to calculate the maximum, because the normal stress we have and shear stress we have on oblique plane, but what will be the maximum normal stress? Okay. If I say I am just interested into calculate that maximum normal stress, then what will be the value? So sigma n we have, it is nothing but P by A cos square theta. Okay. If I want to calculate what is the maximum normal stress, so the maximum normal stress sigma n will be maximum. Obviously, then this trigonometric function is what, 1, because what is the value of this cos? theta, if you check, so that variation is what, 0 to 1. Yes or no? So cos 90 will give 0 and cos 0 will give 1. So maximum value, if you check this trigonometric function, so it is 0 to 1. That will be the range, and maximum you will achieve when that trigonometric function value is what, 1. So when it is possible, when theta is what, 0. Simple. When theta is what, 0. So your sigma n max is nothing but p by a, and that will be for the normal plane. That is the one conclusion. Now we'll talk about the uh, what is the minimum value of this normal stress. So definitely minimum value will be 0. Okay, when it is possible, when that plane is what, theta becomes 90, you can say. Now if you say about the maximum shear stress, so tau we have here, check, tau value is nothing but p by 2a sin 2 theta. Okay, now I want tau max. This tau, if I want max, then what will be the value of this? So this sin 2 theta should be maximum. Okay, this sin 2 theta should be maximum, and if you check the value of sin 2 theta, which is the maximum value, again for this trigonometric function also the maximum value is what, 0 to 1. So I can say that maximum value you will get when there is the sin 90. Yes, when there is a sin 90, then only you will get 1. So what will be the theta here? Theta is nothing but 90 by 2. 2 theta is equal to 90. Here you can write 2 theta is what, 90. So theta is nothing but 45. So exactly at 45 degree, you will achieve that tau max. Okay. So tau max you will achieve when theta is what, 45. That is for 1 marks aptitude, that you need to remember. And what will be the value? The value will be p by 2a sin 2 theta. Theta is nothing but 45 sin 90. That means tau max is nothing but p divided by 2a. Okay, that you need to remember. Now you can think any material which is going to break due to shear stress. So for that, what will be the angle? That angle will be 45. So that's the reason many times you have seen the chalk piece. No? This is what chalk piece, suppose. This is the chalk piece. No? White chalk piece. Now if you apply the twisting moment, you just hold one end, hold this one end for this chalk, and another end you just rotate. So if you check, it will be breaking, this chalk will be breaking. Okay, this chalk will be breaking with 45 degree angle, because you have break that chalk with the shearing stress. So it should be a 45, because at 45 that shear stress will be maximum, and because of that maximum shear stress, it will be a failed. I mean, it will be breaked. Understood? It will be broken. So this is the only practical thing I am saying. This is the 45 degree. And why it is breaking? Because of the twisting moment. If you say twisting moment, then shear stress will come, tau, and tau max will be what, p by 2a. That you need to remember, just for information only. This formula you need to remember. Tau maximum you will get at theta is equal to a 45. That is very important. The concept of complementary stress, you know that already I had discussed. That complementary stresses, it is acting exactly at 90 degree. By the magnitude, it is equal and opposite. That also already I have told you, called complementary stress. Fine. So now that 3D stress system we already had seen. 3D stress system we had seen in last class, and for that matrices I had shown, and that matrices what, sigma xx, and it was tau xy, it was tau xz, then we have tau yx, sigma yy, and it is tau yz, then it is tau zx, tau zy, and sigma z. This is the 3D stress tensor. Okay, but now if you are going for the, like already I had discussed, because if you talk about the 3D stress systems, it will be some kind of difficulties you may get in the formulation, in the calculation and all. So for the simplicity purpose, I mean just you want to make that calculation simple as much as possible, so you will consider 2D stress system, and that 2D stress system also called as a biaxial 2D stress system, also called biaxial system. Okay, it is called biaxial system. Biaxial stress system, or it is also called plane stress system. Why it is called plane stress system, that is also one discussion we'll have here. Plane stress system, these are the name. Okay, so this 3D is just for, like, you must know about all three axes, you must know all the stress distribution and all. In calculation point of view, always you consider 2D stress system. So this is the 3D stress system, and we had seen, yes, last lecture, that sigma xx here, this is x axis, this is y axis, and somewhere here this is what z. So this is what sigma zz, this is what sigma yy, and already this was the tau xy, this was the tau x, already I had discussed. Similarly we have uh, tau xy here, and this is what tau yx, and this is the tau yz, that already I had discussed in my last lecture. You can go and check. Now if you talk about the 2D stress system, so that time you can z axis assume to be 0. Okay, you can say that z axis you can assume to be 0. That will tell you, like, it is nothing but also called as plane stress system. So that means, or you also can say that assume thickness is negligible. Thickness is negligible. If thickness is what negligible, okay, if thickness is what negligible, that means z axis you are assuming it is 0. So obviously if there is no z axis, then what will be the stress in z direction? Sigma zz 0. Tau in z axis it will be 0. Tau in y z, this will be 0, and obviously tau xz is 0, then tau zx, because it's complementary stress. If tau yz is 0, then tau zy also 0. So because it's a complementary stress, so here you can, if you want, you can mention here. So for the plane strain, for the plane, this is also very important. Okay, plane stress, and which is also called 2D stress system. So here you assume sigma z is 0, tau x is 0, tau xz is 0, then complementary stress tau zx will also be 0, tau yz 0, complementary stress tau zy will also be 0. Already I have discussed what is the complementary stress. So these 5 stresses, that may be 0. Now if you check the matrices, so what will be the matrices now for the 2D stress system? So we have 2D stress system, and for this, that stress will be sigma xx tau xy, tau xz will be 0. Then next tau yx, sigma yy, and tau yz will be 0. Okay. Then here tau zx will be 0, tau zy will be 0, and sigma zz. So this will be the stress. So now this stress matrices you will have 2 by 2. Earlier it was 3 by 3. Check. So for the 3D stress system it was 3 by 3. Now for the 2D stress system you have 2 by 2, which is nothing but sigma xx, sigma yy, tau xy, tau yx. Now if you check the plane for this, so now you have only xy plane. That indicates xy plane. And if you talk about the plane stress, so that it indicates it's a xy plane. But the condition you are assuming z axis has to be 0. But it doesn't mean always z axis has to be 0. You can say x axis also can be 0. So that time you will have yz plane. Or you can, your assumption, you can say y axis, that thickness negligible means you can say y axis will be 0. Then you have xz plane. But generally we avoid x and y to be 0, because in practical we have xy plane. Most of time 99% we are using xy plane. So for our simplification purpose we must say okay, z axis assumed to be 0, that thickness is what negligible in z direction. So z axis assumed to be 0, and you will have only xy plane. So if you are saying z axis assumed to be 0, then you have only xy plane. So now whatever the stress system you may have, that will be for only xy plane. So it's very simple for xy plane. Now check, I will draw the all the stress here. So you can say this is what x and this is what y, axis y. So this is x and this is what y. So for this x and y, if you draw the stress system, now this is the plane, xy plane. You have xy plane, because perpendicular to the xy plane we have z, and we assume that z is what negligible, because thickness is what negligible we have assumed. Hence z axis will be 0. For that reason all the stresses. So this is the gate. Okay, they may ask sometimes plane stress condition. So if it is plane stress condition, then sigma zz will be 0, tau xz will be 0, tau yz will be 0. So tau xz, tau yz, if you say, that is sufficient, because if your tau xz is 0, then complementary stress for tau xz will be tau zx, and that will also be 0. Similarly, if tau yz is 0, then complementary stress for tau yz will be tau zy, so that also be 0. So better you say this 3 only. Okay, this 3 you make practice for this 3 only, and this tau zx and tau zy, it is your understanding, because tau xz is 0, then tau zx will be 0. Why? Because it's a complementary stress. But always remember, if it is plane stress condition, then 3 stress will be 0: sigma zz, tau xz, and tau y. Always remember, it's very important. Okay, they had asked in exam for 1 mark. Anyway, now so all the stress system for the axial, we have to talk only xy plane. Now hope this one is clear. Okay. Now so again I will give this heading 2D, okay, which is also called biaxial, which is also called plane stress system. Now so it should be fixed in your mind, we have only xy plane. Okay, we have, because we are considering plane stress system, we are considering 2D, we are considering biaxial. So now in this situation, all the stresses will be developing in one perpendicular plane only. That's the reason it is also called plane stress. Okay. Okay. Now that example is very simple. Beam, you can take example for the plane stress. We can take example shaft or any thin member. So if I say plane stress system, so that means it's a thin member. Okay, thin member. thickness you have assumed 0. Now, so for the 2D stress system, so we have sigma xx, tau xy, tau yx, and and sigma yy. This will be the matrix you have to talk now. And if you want to draw these stresses on the plane, so the plane will be only xy plane you have. I will show all the stresses here on this plane, xy plane. So I have shown you x-axis and y-axis. Now I will show the stresses. So this stress will be sigma xx. So obviously this face will also be a sigma xx. This is the sigma yy, and this is called 2D stress system or biaxial stress. Why it is called biaxial? Biaxial in the sense in two direction. Bi, uni means one direction. Bi means two direction. Triaxial means three direction. So that is the word you need to remember. Now, so stresses you have shown, but what about shear stresses? You need to show the shear stresses also. So shear stresses will be, this will be the shear stresses you need to discuss. It is nothing but tau xy and tau yx. Yes or no? Where is the tau yx? This will be the tau yx, and what is this? This is the tau. I have shown you why this both are in this way, because it's a complementary stress. So that is showing tau yx is equal to tau xy, and that is also showing by magnitude it is same, but in direction it is just opposite. So sign convention it is showing, okay, just opposite, equal and opposite. That is the complementary stress, equal and opposite. All right, fine. Now, so here we have to discuss for this biaxial stress system also you may have the oblique plane, okay, and for the oblique plane they will ask you calculate what is the stresses. So for anywhere for oblique plane, if you go, you will have two stresses. What are these two stresses? It's a normal stress and shear stress, and that normal stress and shear stress you need to calculate. That is your job. That's all only, okay. And for that we have formula, but I must say that formula you need to remember. We have derivation as well, but derivation is not important at all for this, I would say, because see, if you go for the derivation and all, it will waste your time. You are not going to write the exam. You are going to mark that answer. It is not subjective for 8 marks or something. So I would say, take any textbook, you go for derivation, here directly formula I will give. I will explain all the aspects, then formula will write and will go for the numerical. Okay. So I can draw another diagram, and for that we have to go and calculate the stresses on the oblique plane. So for the biaxial stress system, where you will get the oblique plane, check. This is the biaxial stress system here. This is the biaxial stress system, and for this we have sigma xx. This is sigma xx, sigma yy. So on both x and y direction I am taking tensile load or tensile stress, but it doesn't mean we should not have a compressive. We should also have, but with somewhere, suppose in x or y direction we have compressive by nature, then that value you take negative. Okay, so here I am taking all, I mean x and y both I am taking tensile. Okay, this direction is called tensile. If the this arrow head is what coming outside, then it is tensile. If this arrow head is what going inside, then it will be compressive by nature. So in numerical, suppose somewhere it is given compressive, so that value you need to take negative and put in formula. That is your job you have to do. Now, where will be the oblique plane? Should see, you can say the oblique plane here you are considering. You can say this is the oblique plane now. Just say for this oblique plane you want to calculate, this is nothing but you say this is a better, this is B, and this is C. So for this oblique plane, you are interested to calculate the stresses. So here this is B, this is C, this is A, and this angle is what? Theta. Anywhere they can give this angle also. I will tell you what to do. I am considering this angle, and on basis of this I am just going to calculate the value of the normal stress. So obviously this is the inclined plane, and because thickness is what? Negligible, so you may get this is now it will be treated like a lamina. Okay, lamina means that thickness is what? Negligible. Now over this oblique plane I am just going to calculate that value, which is nothing but normal stress. So I must say this normal stress is nothing but over this inclined plane it will be sigma n, and obviously somewhere you will have shear stress on this plane. So shear stress will be here tau. So in z direction thickness is what? Negligible. You forget about z, only x and y. So if you talk about x and y, then how this oblique plane will appear, that I will show. Z is what? Just hypothetical assumption. Rest for any thin section you talk only xy plane. So now if you talk about xy plane, so this is the oblique plane here. Check. So this oblique plane will appear like this. This is the plane now. You can assume okay. So for this oblique plane, I will draw the hash lines. It will be more clear to you. So now for this oblique plane, we are interested to calculate the value of normal stress and shear stress. Always remember. This is what? Sorry. Sorry. So for this plane, here we are calculating normal stress. Hope this one is clear to you. Okay. So for this, this is nothing but tau. The arrow mark yellow color I have given. This is the tau shear stress. Later I will draw. This is the shear stress, and exactly normal to this. This is what? Normal. Normal to the plane. Okay. And if you check the angle between this normal stress and shear stress, it should be 90 degree, and it is like 90 degrees. See this way. So this is what? Sigma n, and this is what? Tau. Okay. Always remember. And what angle I am talking? This is the angle theta. So sometimes what they will do? Sometimes they will do this angle theta. So that time nothing to worry. It's very simple. Okay. Okay. Now, so if you calculate what is the value of sigma n, so you need to derive. This is the normal. Normal stress on plane BC. This is B, this is B dash, this is C, this is C dash. Okay. So sigma n will be, and similarly we have shear stress also. So sigma n first need to write here. So sigma n is nothing but sigma x. So this sigma xx also I can write, for my simplicity I can write sigma x. Similarly sigma yy I can write sigma y. Okay. So sigma x plus, this is the derivation here, sigma x plus sigma y by 2 plus, after derivation this value will come sigma x minus sigma y by 2 cos 2 theta plus tau xy sin theta. So this is the derivation actually. Here directly I am writing because I am considering that derivation is not important. Similarly, shear stress on plane BC. So if you go for the shear stress on inclined plane is the BC. So what is the tau? So I can say tau is nothing but here. It's a sigma x sigma y by 2. Okay, I will write again, don't worry. Sin 2 theta minus tau xy cos 2 theta. This value you need to remember. This formula, both formula I am saying, this formula number 1 and formula number 2. So this formula, both formula are valid only for the given elements. If I say given elements, in the sense for this sigma x, for this sigma y, for this tau xy value, for this theta value. If anything will be changing, accordingly in formula you can change the thing. Like example point of view, I can say that value of direction of here, sorry, I forget to show that direction of the tau xy here. So this will be the tau xy, na? I should show that here space. So this is the tau xy and here this is the tau xy. Fine. Now for this I have taken one inclined plane and that is the angle theta here. The separate I have drawn here, and for this I have written this. I have drawn this diagram so that it can clear properly. And here sigma n and theta I mean sigma n and tau I have written. So based on this you need to calculate the value. That's all, simple. Okay. Now, so again at least one numerical we need to do, so it will be more clear to you. So see, I will show you like how to manipulate this. If suppose something will change, then how this formula will be changing. So that I should show. So see our basic is what this formulation. I will draw the diagram once and I will write the formula again, so it will be very clear to you. See, for me it was given like this. For me it was given 2D stress system like this. This was sigma xx, sigma yy, sigma xx, sigma yy, tau yx, tau xy, and they said they had taken one inclined plane, and that inclined plane was, you can say, B and C. So this is the B and C, and from the vertical this angle is what? Theta. So this angle theta I have taken, and this is what A. So this is what sigma n, and this is what tau. Okay. So here whatever the formula you have written sigma n is equal to, once again, sigma n means normal stress, and this normal stress you have written sigma x plus sigma y divided by 2, sigma x minus sigma y divided by 2 cos 2 theta plus shear stress tau xy sin 2 theta. And similarly shear stress here you got for this oblique plane, sigma x minus sigma y by 2 plus sin 2 theta minus tau xy cos 2 theta. This is the Very important and very wonderful formula. Now you can relate this. What earlier you had, it was uniaxial, and for uniaxial on oblique plane you had calculated value. See here, for the uniaxial oblique plane you had calculated value. This was the normal stress P by A cos square theta, and this is the tau P by 2A sin 2 theta. Okay, so but the thing was only one like P by A you can write it stress, so it will be sigma cos square theta, and this will be sigma by 2 sin 2 theta. So only one stress, you can say sigma x you have. Now in the same formula here, what we have, for the same formula you can take that sigma y is equal to 0, and rest other calculation you check. Okay, so you will get the same formula like you had seen earlier. You will get the same way, that formula you will get. Okay, anyway, so sigma and tau you will get, you can do by your own, you may get that. Now for this we have formula. Now the problem is what change, like the problem is what, like this is the problem we are going to do. So see, for this problem how this formula will be manipulated. So I'm just going to write this problem number 1. For this problem I want sigma and normal stress as well as tau shear stress, and for me the diagram is what given for that problem. The diagram is not like this. See, so for this diagram how your formula will be manipulated. Check. You can say here the stress is given 30 megapascal, okay, this is what given 60 megapascal, okay, this is given this is given 20 megapascal, it is given 30 degrees BC. They said calculate this normal stress on inclined plane, and inclined plane naming I have given BC. So now check. So for BC they are talking, then what you will do here, you just take this inclined plane here. This is the inclined plane B. C. Take this now A. Okay. What angle they have given? They have given this angle. How much? 30 degree. Okay. Here you need to calculate the value of sigma n and tau. This value you need to calculate. So you can use your formula, previous formula. How you can use? Check, for this formula is basically for this. See, theta was from vertical, but here this theta they have given from horizontal. So first of all you will make the vertical angle. So what will be this angle? This is 90. So 90 minus 30, this will be 60. So in problem, like in formula, what formula you have, everywhere theta value you have to write this 60, not 30. They have given 30, but what you have to write this angle from vertical, because this derivation you have written here, that angle which is from vertical. See this diagram. So for that reason I am solving one problem, so at least the thing should be clear. Okay, so now this one is clear, angle wise this is clear. Second thing, check this sigma xx, whatever the sigma xx in the formula here, whatever you have taken, This sigma xx for tensile. This is going, arrowhead is going outward. That means tensile. So it will be a positive. But here in this case, this is what compression. So whatever the value you will have, it will be minus 30 megapascal. Okay. Coming to sigma yy. In your actual sigma y is tensile. For tensile you have written formula, but here also tensile, hence it will be positive, so you write 60 megapascal. Coming to the shear stress, because shear stress we have a sign convention. See, in the shear stress if you check, so in the shear stress it is nothing but, see, this shear stress tau, that complementary stresses, that arrowhead is what going towards to each other. Okay, for that you have written this tau xy. But here in this case, this arrowhead is what going in your problem. This arrowhead is what going outward. So this tau xy will be negative minus 20. This much manipulation you have. Rest everything is what same. Now if you write the formula of sigma n, so everywhere if I say sigma n, so this sigma n is nothing but sigma x, which is nothing but negative. So direct I will write here. So negative, so it is minus 30 plus sigma y, which is nothing but 60, I think. 60, or should I write one more time formula? Better one more time I will write formula, so it will be very clear to you. Okay, so sigma n formula, what I remember, it is sigma x plus sigma y by 2. Okay, plus, please remember this formula, sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Now you keep the data. Sigma x will be negative. Why? Because it's a compressive, so minus 30. So now directly I will write the value 30. Sigma y is nothing but given 60 divided by 2 plus, again sigma x is what negative, so minus 30 minus sigma y, it is negative in the formula, so it is negative 2 cos 2. Now check what theta they had given. They had given 30 degree, but you have written as in your format 60 degree should be here. So what angle you have to write here? You have to write 60 degree. That was my point. Because this formula what you are writing, that formula is what for the vertical angle theta. Hope you understood what my point is. So, and then tau xy is negative, so negative, what is the value of tau xy? It is 20, so minus 20. All values are in megapascal, so nothing to worry. Tau sin 2 into 60. So this will be the value of sigma n. So it should be 20.18, nearby this 18 megapascal. So this value is what? Positive, so take as it is. Okay, because chances are there for negative also. Okay, now this is about normal stress. Now we'll go for the shear stress. So we'll write the formula for the shear stress here. Tau we have shear stress on plane. On inclined plane it is sigma x minus sigma y by 2. Okay, then we have sin 2 theta minus tau xy cos theta. You keep the value. So sigma x is what? Negative minus 30 minus 60 by 2 sin 2 theta, you got 60 degree as per your requirement, minus tau xy is negative, so minus plus 20 megapascal is the tau xy into cos 2 into 50. You calculate tau value. So this value is what? Minus 48.97 megapascal. So positive and negative, it can be anything, so it doesn't bother about it. Okay, the point is, now if you want to show that inclined plane, suppose this is the inclined plane now, and here now if you want to show the stress, so this angle they had given 30 degree. So for this is what A, this is B, and this is C, inclined plane. So here sigma n was positive. Check, sigma n was positive 20.18 megapascal. So So means whatever the direction of sigma n, it was like this only. So sigma n as it is, okay, and this value you already have calculated. This is nothing but 20.18. So you can write 20.18 megapascal. But as per your sign convention, tau was downward. Check in the problem here. Check tau. You have taken tau downward, or in your original formula. See, this tau was in downward, but now you are getting tau negative. So what is the mean of it? It's meaning the actual tau direction, which is the shear stress on the inclined plane, will be just opposite. Now, if you are inverted this direction, then this magnitude only you need to write, because this inverted direction itself will say like, okay, this value is what you are getting negative, hence you have inverted this direction. That's all. So this is the sigma and n and tau for the inclined plane. Hope you understood this.